Welcome to our 14th class today. Don't worry about the class today. Also, I will provide the recorded video of the class. And if we have any trouble with the class time for the next classes, probably we may schedule it for our weekdays, right? So that's not a problem. So we were yesterday we were talking about a Raspberry Pi, how to install the operating system, how it works, and how we navigated through those kinds of things. Today also we are going to look for Raspberry Pi, right? Before we move on to that one, do you have any problems or difficulties or any questions to ask me? You can just go on. If you have any problem or questions, you can ask me. Right. So we will get back to another video. Today also we are going to see another type of video. So basically we are going to, today we are going to control the electronics components by using our computer, right? That is what today we are going to see, right? It's like playing games, right? So what happened if you press, let's say as an example in your maybe your video games, you press forward backward arrow, then the display will show you, right? So according to that we are going to play around with the electronics with our keyboard, right? That is what today we are going to see. Hopefully our next classes, right? So next classes I'm going to give it to you, right? So that means according to your desire, right? Maybe if you want to learn programming, you can just say that we want to learn programming for Arduino. So I will teach Arduino programming, right? So if you want to learn how to project management, that means how to achieve a particular project within a predetermined time, right? How we schedule the project, how we obtain the things, and those kinds of things, right? So if you want to learn those things, you can ask me. We want to learn that one. That means project management. So then I will teach you project management, right? So if whatever regarding this one, whatever you want in regarding this robotics, I will teach you. I will try to teach you if I know, right? So so this is the you know that this is a Raspberry Pi operating system. We have to connect it our Raspberry Pi with the monitor, keyboard, and the mouse, right? And also it is attached with the Wi-Fi if you want, right? So this is the Raspberry Pi interface, right? So so what we have to do is we have to click this one, Raspberry Pi, and we are going to open Scratch, right? So here we are going to control today the basic lesson. We are going to control the LED bulbs, right? These kinds of, yeah, yesterday we saw according to the predetermined time we controlled that one. But today class we are going to control the electronics components such as LED bulbs or motors, motor controllers, servo motors, whatever the thing you want, we can control it, right? But we are going to control it by using our mouse or keyboard, right? That is what we are going to see today. So maybe you don't hear the sound, right? So I will share this again. So now you may hear the sound.
All we're going to need today is 2 patch cables and one 220 ohm resistor. Although any other resistor value should work, your LED might not be as bright if you have a particularly high value. And then a normal red LED. So the way we're going to set this up is by just putting our LED into the breadboard to begin with. Now you want to make sure you know which side is the positive and which side is the negative side of your LED. You can usually tell because one of the legs will be slightly shorter than the other, and that is the negative side. But if you can't see that, if you look carefully at your LED, you can see on one side it is totally circular, and on the other side it has sort of a flat edge. And that's another way of telling if the LED is positive or negative on either side. So let's put it into our breadboard like this, with the positive side on the left here, and the negative side on the right. And now we take our resistor, and we want to make sure that one of the legs of the resistor is in the same line in this direction as the positive line of the LED, and then the other leg can go in somewhere along here. There we go. Now, we also want to make sure that we can attach it to our Raspberry Pi, so we do that by attaching one of these cables to one leg of the resistor. This is the positive side, so this is going to go to our GPIO pin. And we take our other cable and attach it to the negative or ground side of our LED, and this one will be going to ground. So, exactly where are we going to plug these in today? Well, we want to use...
So you may notice that he used a male to female cable, because in Raspberry Pi we have male pins. So we have to use these kinds of pins to connect.
GPIO pin number 5. So if we look on our handy little chart.
So I told you to print this kind of chart, whatever the Raspberry Pi you are using. We have to obtain a printout. So, or maybe we can see that one according to this chart, right? So we can easily download this one from the internet, and according to this chart we have to wire, right? So it is very simple. We have to obtain a GPIO pin, whatever the pin you like, and we have to connect it.
Here we can see that GPIO pin number 5 is here, and that is what, 6 or 7 pins in from the bottom. 1, 2, 3, 4, 5, 6. So if we count carefully, we can go 1, 2, 3, 4, 5, 6. And 2, 3, 4, 5, 6. Always count twice. And we can see from the same chart that if we want to plug it into ground, next to GPIO pin number 5 is a ground pin. So we can just stick our ground pin on this side of it. So have a quick check over once again, just to make sure that you've got all of these things in line. And once you're sure that all of these things are absolutely...
So this is very simple. This is how we connect an LED bulb with Raspberry Pi, right? If you can connect the LED bulb, that means you can connect whatever the components, because it is in the
right and in place. Take your power cord and boot up your Raspberry Pi. So to get started, we go to the Raspberry menu and look under Programming and select Scratch 2, and it will open up with the example project that is already there. Before we can get started with the Raspberry Pi though, we have to add a couple of things, because you can do a lot of great things with Scratch already, but to make the GPIO pins on the Raspberry Pi work, we need to navigate to More Blocks.
So in Scratch 2, that means Scratch 2.0 version, we have to go here. But if it is Raspberry Pi Scratch 3.0, here we have another icon to click, right? So here we have to add the extension for the GPIO pins, right? General purpose input and output pins. That means this program can read that Raspberry Pi pins also, right? That is why we have to add an extension.
And add an extension and select pi.gpio. And what this will do,
so after you click that one, it will have this kind
of, it will give us
pins, right?
the option.
GPIO pin to output high, GPIO is high. So it is asking, this is a sensor, right? So if you want to attach any kinds of sensors, you have to use this one. But if you are using an output, that means you say the GPIO 5th pin to be high, you can use this one, because we know that if this shape is used, that means this is an output. Right? If you use this one, that means this is used to sense. Right? The sensors may be attached to this according to those pins.
To set our GPI pins to high and low. So let's look at how we'd make a program where you press a button and that changes the pin to high or low and turns our LED on or off.
Right. So in your keyboard, if you press any kind of key, you can program it, right? Whatever the key you want to press, you can program it, right? Maybe you may set that in your keyboard key, A is pressed. When A key is pressed, the LED bulb should turn on, right? You can program whatever you want, right? So if D key is pressed, that means the LED bulb will be turned on for 5 seconds and then turn off. Likewise, you can program it, right? These are very simple things you can program, right? So likewise, you may create some kinds of different projects, right? Different projects, different games also you can create by using this one.
So to get started with our little program, let's drag our little cat over to the left side of the screen here and add something we can use as a button to click on. So down here in the sprites part of the screen, if you click this little face here, it'll allow you to choose a new sprite from their library. And I think this arrow looks good. So let's click OK. And it'll give us the arrow, which we can now drag up to the top of the screen. Now we want to start by making our blocks of...
So what he is doing is, he's setting a key here. If you click this key, then the cat will move, right? So that
code for our little cat. So make sure that you have the cat selected in the sprites menu just here. You can also just click on the cat itself. And you'll know if you have the right thing selected because up in the top right here, it'll show a picture of a cat rather than the picture of the arrow. So what do we want to happen with our cat? Well, we want every time that this arrow is clicked, we'd like the cat to move. So we're going to tell it to move 10 steps. And we also want...
Right. So whenever we touch, that means we click this arrow, the cat should move in this direction, right direction, right? So that is what he is programming. So we can program it according to
GPIO pin.
So we have to, this is output. You know that this is, if this shape is used, that means this is an output, right? So we have to place inputs
where we've already put our LED to turn on. So in the more blocks menu here, we can drag GPIO under.
So if you select this one, that means the Raspberry Pi pins, we have to drag and drop the Raspberry Pi pins also, right? That means the LED bulbs will also be activated. That means the GPIO pins also will be activated. So we can work.
Move 10 steps, which means that we've done just after the 10 steps have been moved. And in this little hole here, we want to select and enter the number of our GPIO pin.
So he has connected the 5th pin as the LED bulb. So that is why he's selecting.
We had it set up today just on GPIO pin number 5, but if your GPIO pin is different, just have a look at your chart and make sure you put the right number in.
So basically, the Scratch software is very easy to program, right? So in order to have the Scratch program inbuilt, that means already installed in your Raspberry Pi, you have to download the 2.3 GB version, right? In the raspberrypi.org website, you have to download the highest GB storage software, right? So then these kinds of softwares are pre-installed with SD card. So then you have to install it on your Raspberry Pi, right? So if you don't install it, we have to manually install each and every software. That may be increase the difficulty of the project, right? So make sure that you download the highest GB software from raspberrypi.org and then install it on your SD card.
In here. And once this has been turned on, we want it to stay on for just a short moment, and then we want it to turn off again. So if we look in the control menu, there is a thing here that says wait 1 second. That seems about the right amount of time. So we'll clip that onto the bottom of our GPIO block here, go back to more blocks, and drag the GPIO block out here. Once again, we want it to be the same pin, so GPIO number 5, but we want to set it to output low. Now, right now, this will only do something if we click on it and just tell it to do it. But what we want to happen is every time we click on our arrow, then it will carry this out. So if we now click on the arrow down here, we can use a different thing in here called an event in order to make this work. Specifically, we need to send a message. So every single time that this is clicked, we want it to send a message to our cat here. So we can use this block, which is when the sprite is clicked, it'll do whatever is beneath it. And we can also use broadcast, which will send a message out to everything with whatever we have written here. So we don't have to change it from message 1, but I am going to add a new message, which is go. So every single time this is clicked, it broadcasts the message go to everything else. Now, it's quite simple. We only have 2 things. So we can go back to our cat now. And on the same events menu, when it receives go, we can just put that on the top, which means every single time that the arrow sends the message go, the cat will receive it and move.
So do you understand the program, right? So basically what he has done is simple, right? So he has programmed like if this arrow is clicked, right? When this sprite is clicked, we call it the characters as sprites. This one is a sprite, this one is a sprite, right? So these are sprites, right? So when you have to select this one, right? So when the sprite is clicked, that means this sprite is clicked, right? So we have to click first one, this one, then we have to drag and drop this one. When the sprite is clicked, right, then it will send a message. If it is clicked, then it will send a message, right? So message you may program whatever you want. He has programmed as go, right? If it is clicked, it will send a message go, right? That's all, right? That's all about this one, right? So for this one, we have to select this particular sprite, and then he has attached an input, right? So then for this arrow, go message is an output. You can see this one. This is an output, right? So for this one, this particular sprite, go message is an input, right? So for the program, if the go message is received, that means input is received, then the cat will go and also the LED bulb will turn on. That is what he has programmed, right? So if you don't understand the program, you can ask me.
And if you look down at your breadboard now, you should notice that every time you click this arrow.
So if you click that one, then the LED bulb will turn on and also the sprite will move 10 steps right towards right. That is what the program. Now you have got an idea about how these things are working, right? So according to this one, you can program whatever you like, right? So you may program as if the keyboard right arrow is pressed, then these are the things that are going to happen. So according to that one, you can
the LED will come on and turn off again after 1 second. So our program works now. When we press the button, he moves and the LED turns on or off. But what happens when our cat gets all the way over to this other side of the screen and we keep pressing the button? Well, they go off the screen and there's not much we can do about it. So let's move them back to where they began and change our code so that every time the cat gets to the side of the screen, it automatically comes back to the start and the game can go on forever and ever and ever. So,
right, this is like a game, right? So we are creating a game. So if the cat has touched this one, then the cat should come to this position, initial position, right? For that, we are going to program.
So to do this, we need to look into our controls. What we need is if the cat hits the side of this screen, it needs to go back to the left side of the screen. So we use this if-then statement.
So we
know we want to connect it to the bottom of our block here because we know we want to do it after it's moved and turn the light on or off. And after each one of these, if it is touching the edge, we want to send it back. So we use the sensing blocks to work this out. And the top one here says if it is touching. So we drag that into the little diamond shaped thing here. You'll know it's right because it glows when you put the mouse over it. And we want to change it from mouse pointer to edge. So if it is touching the edge of the screen.
So you can simply read and understand this program, right? If touching edge, right? So that is what these programs are very easy and simple to understand.
Screen,
right?
at the end
So
of this
if
movement,
touching
it will
this
do
edge,
whatever is in here.
it will come to the
So
initial
what do we want to
position,
do in here?
right? It's very simple.
Well, we want to move it. So let's look under the motion menu. And if you look, there is a go to here. So
there is a difference, right? So move to 10 step means move, it will move, right? So go to means it will set to that position. That means set to that particular coordinate, right? So initially it has now it has the coordinate of x minus 181 and y3. That means if you see this is x, right? This is y direction. Maybe I will draw here, right? Maybe this is x direction, this is y direction, right? So x is minus 181. So probably this one. So just give me a minute, right? So the coordinate will be like x and y minus x, like this one. Right? So this is x, this is y. Minus 181, maybe minus 181, minus 181. Right? So maybe this cat is at 3. Y is equal to 3. This is the initial position of the cat. Right? So when it is touched, right? So it has to come to its initial position. Right? So we can set this as this one, or we can set it to come here, right? So that means it should come to 0, 0. That means x 0 and y also 0. That is the origin. That means we call it this position, this point, right? So we can program.
let's drag that into the block right here. And these values that are in here are actually where.
So here, these values are located here. These are initial positions. If you want, we can.
Where our character is already. So we don't need to change them. But let's say that you actually decided you wanted to start your character somewhere a little bit different. Let's say we wanted to put him a little bit further down here. Then what you can do is just put your mouse cursor over him, and you'll see in the bottom right-hand side of the screen here, the values that you want to write down. So in this case, it's minus 184 and minus 68. I'm going to put that in here just to make it slightly easier to remember. I'm actually going to say minus 185. And I've already forgotten the other one. It was minus 67. Let's just say minus 70. Minus 70. So now, whenever it's touching the edge, it should move back over. So if we press our button, let's speed it up just a little bit. And we keep pressing our button. As soon as it hits the edge, it sends him back to the start so that we can keep going with this game forever. So this has been an introduction to using Scratch on the Raspberry Pi. There's a whole load of stuff you can do within Scratch. You can trigger sounds, and you can use all kinds of different things with the GPIO blocks of your Raspberry Pi. You don't have to necessarily attach it.
Right, so we can program it according to that one. Right, so another thing that we are going to see is we are going to deal with this one, right? So we are going to deal with this one, right? If the keyboard arrow keys are pressed, then this robot should work accordingly, right? So it is like playing games, right? So if you press the front arrow, and the robot should go forward direction, right? So if you press back arrow, then it will go in backward direction. Likewise, it should turn left side and right side also, right? For that, we have to use a motor controller as well in order to control these motors, right? So we know how to wire these things, right? So in the motor controller, right? We can use these two pins, and these two motors are connected here and here, here and here, right? So here we have 8 pins, right? Maybe enable A and enable B are short circuited. These are, here we have in 1, in 2, in 3, and in 4 pins, right? So these pins in 1, in 2, in 3, and in 4 pins are attached to the Raspberry Pi. Maybe you can program, right? Maybe I can attach it GPIO 1, GPIO 2, GPIO 3, GPIO 4 pins. Likewise, right? GPIO pins, right? Then we can easily control, right? So if the front arrow in your keyboard is pressed, right? Then GPIO pin 1 and GPIO pin 3 should be powered up. That means it will provide the signal to this motor controller, right? After the signal is arrived, this motor controller will activate these motors and the robot will move in forward direction, right? That is the simple task. If we press the front arrow, right, up arrow, and then the robot will move in forward direction. If we press the back arrow, and the robot will move in backward direction. For that, we have to program. In order to move the robot in backward direction, we have to program this as, how we can program. We have to give power to 2 second pin and 4th pin. Then it will move in backward direction. Right? This is very simple. Watch this video and we will have a look.
So previously we've got the GoPiGo assembled, we've got it hooked up and connected to Wi-Fi, and our computer.
So this is introduction. So we don't need this one. So this is basically he's telling that how to assemble the components, right? So probably most of the students can assemble these things, right? So we can have the screws and nut and bolts with arranged with.
And the password is
right?
Raspberry if you're using the Raspberry Pi image from Dexter Industries. So hit OK, and boom, I've got my desktop here. This is connecting GoPiGo ground plate between Scratch. We'll start that. See, it comes Scratch to Go, and
right. This is the program, right? So you can see that when down arrow key pressed, right, broadcast backward. That means when the down arrow key in your keyboard is pressed, it will send a message, right? As we saw earlier in turning on the LED bulb, it will send a message called as backward, right? So if the backward message, then for this down arrow, the backward message is an output, right? For this one, right? So for which one? So here on the downside, when, so he has to program that one, right? So when the backward signal is detected, then in 1 and in 3 pins should, in 2 and in 4 pins should be activated, right? That is what the program states that. Similarly, you can program those other things as well.
Great. So let's go back real quick to the LX terminal that we had running with the background program. We'll see that we're sort of connected. So if I pull that up, we see right after the last error, we see connected to Scratch successfully. So with my GoPiGo running, I can test out some of the LEDs. You can see how we've structured the program in here. It's just going to respond to the keyboard. So an up arrow will move it forward. Left arrow, when that's, it'll tell the GoPiGo to go left, and it'll say left up here on the Scratch screen. And I can also control some of the
So also in the monitor, we can say that it should work like this, right? That means that it will say left side, right side. That is what this program states that, right? So if the backward key is pressed, then say backward, then it will say that backward. And also, if you if you say the GPI opens to operate by using this message, you can also program. These are the simple
Yeah.
things.
You can kind of hear in the background. If you hit the space key, it'll stop it. So we can test the LEDs by hitting a L. The right LEDs are off, and a K where the right LEDs are on. So if I go back and forth, I can turn those on and off. And that's pretty much it. You can look at this example, and you can see all of the controls are labeled in pretty understandable language. Whether you the GoPyGo goes.
So the difference is he is using Scratch 1.0, right? So do you understand this? He is using a Scratch 1.0, right? So in 1.0, he has to program this with another one, right? So it is better to use Scratch 2.0 version, right? On there, we have GPI opens, right? So after this one, say forward, we can also attach the GPI opens to power on, right? So that is how we program, right?
Right or left or forward or back. That's a test.
To show you the GoPyGo in action, I've got the Scratch program up and running on VNC. So I'm logged into the Raspberry Pi with VNC. You can see instructions on how to do that on our website. And I've got without it running around my laptop. L key, so if I turning it, and then the K turns it on, and out on my, see the GoPyGo turning on. The GoPyGo running for the arrows on this PyGo. If I hit the back button, it goes backwards. If I hit the left, it goes to the left, and to the right, it goes to the right. Forward goes forward.
You can see the mechanism, right? So what happened? He has turned this one upside down, and he has programmed, right? So that means if the left arrow is pressed, only this motor is rotating, right? If the right arrow is pressed, only this motor is rotating, right? Likewise, you can program.
Backwards, and then spacebar again to stop. That's pretty much it. You can see, if you look through the code, as I said earlier, you can see how...
So you know that this is how it works, and we can also program that one, right? So up to now, do you have any problems or difficulties? You can ask me. Right. If you don't have any questions, we will introduce another software, right, called as Fritzing, right? In also our previous lectures also, I told you that I have the software with me, and if you want, I will provide you in our, I will provide you. So this software is also similar to Tinkercad, but the difference is we can't simulate, right? We can't simulate by using this software, right? But we can arrange. There are tons of components, and we can arrange these things, right? Those who don't have Raspberry Pi, they can practice by using this software, right? This particular Fritzing software, they can practice, right? So the good thing is, right? So the good thing is, we can automatically generate the schematic diagram and the PCB board from this diagram, right? That is a special thing. So here we have a Raspberry Pi. We have to search this one, right? So I think I'm going to explain this one, right? So I have to explain, because here we have the components list, right? So here we have, there are tons and tons of components. We can also search by typing here, right? So I'm going to type Raspberry Pi, Raspberry, right? So here we can obtain the different Raspberry Pis, right? So I'm going to obtain a Raspberry Pi 3, right? So here I have to drag and drop there, right? This is the Raspberry Pi. This is how it will look like, right? So here we have the GPIO pins, right? So here we have to attach LED bulbs, right? So we have to type LED, right? So then it will appear LED bulb. You have to select it. Wait for it to load. Right. So here we can select the component and simply drag and drop there. Right. Simply we can drag and drop there. Right? So this one is slightly inclined. Right. That means this is the positive. Right. So we can drag and drop this one. It will automatically appear this one. So if you little bit zoom this one, then it shows that these are the green lights. Right. So here we can connect. So basically we have to put a resistor here. So I'm going to insert a resistor. Here we can drag and drop the resistor as well, right? 220 ohm. For the positive side, we have to attach like this. Right? Make sure that it is connected. Right. So now we have to attach the pins. Right. So maybe for this one, this particular one, we have to obtain the chart. That means the Raspberry Pi chart. So basically, we can connect whatever we like it, right? So this one is the left side of our Raspberry Pi. So here we can say that this is the first pin. Right? So this one is the first pin, right? First pin is 3V3, 3.3 voltage power, right? So next thing, that means 2 and 3. 3 is a GPIO2 SDA. So I'm going to connect this for second pin and the ground. Ground is for 1, 2, 3, 4, 5. Fifth pin. So 2 and fifth pin are the culprits, right? So second pin. So I'm going to connect this one and connect this to this one, right? So now we have to ground this one, right? So simply we can drag and drop there. Now we can obtain and connect this one, maybe 2, 4, 5, fifth pin. Likewise, right? Likewise, we have connected this one, right? So similarly, you can arrange another components, right? Maybe you can insert the sensors, right? You can insert IR sensors. You can type IR sensors, motion sensors, whatever the sensor, we learn those things. And we can drag and drop these kinds of sensors and play around with the components. You can make the wiring diagram by using this one. And whenever you obtain the Raspberry Pi, and simply you can program these things by using the Scratch software, right? You can also practice the programming by using the Scratch software, right? So in the Scratch software, maybe Scratch 3, you can practice, right? This is very simple. So we are going to type sensor. So what are the sensors they have? We can obtain. So wait for it to come. So in the meantime, if you have any problem, you can ask me. So here we have a soil moisture sensor, and there are tons of sensors here. Basically, the sensors working principle are same, right? So we know that we have to give power to that sensor, right? Maybe we can obtain 5 voltage from here, and we have to connect this one, right? So we have to obtain this wire and this wire. Right? So that means this one is 5 volt, right? So similarly, we can connect sensor. Maybe I can connect this one. Can rotate this one. Right. So here, if you zoom the pins, you can see that this one is VCC, ground, and signal pin. Right. So we have to give power. Right. So we have to obtain 5 voltage to this one and ground to this one. Right. So then we have to obtain this signal pin. Right. And then signal pin may be connected to one of the components. Right. Maybe this one. So we have to see that particular pin. Maybe this pin is GPIO 3 pin, third pin, right? GPIO 3 pin. Right. Now we have wired up the sensor, right? So similarly we can use. So basically this sensor is used to detect the moisture content of the soil, right? So if the soil moisture content is low, then it will provide the signal, right? So after the signal is come, then we can turn on the LED, right? If you can turn on the LED, that means you can turn on whatever the components, right? Maybe you can obtain a pump, right? So small DC pump. I think we don't have that component. So instead of the pump, we can place a motor because motor is attached with the pump, right? So we can select the component, right? Maybe the motor. This one is DC motor, right? So you can similarly select pump. So basically we don't have pump here, right? So basically the pump will also have 2 terminals, right? One terminal is positive and another one is negative, right? So if you give power to this motor, that means it will operate, right? So here we have a problem, right? Can anyone tell me what is the problem? Can we give power from high voltage here and there? What will happen if I connect this pin to this one and this pin to this one? What will happen? Can anyone elaborate the circuit? What I have done so far for the motor? What will happen if I connect like this? Quickly answer me. What will happen if we connect like this? So basically, we don't have a simulation button here, right? That is the problem, right? So we don't have a simulate button. We can't simulate this one, but we can draw, but we can't simulate and see what will happen, right? But we have to know, be educated people, right? So we learn these things, right? So if you give 5 voltage to this one and ground, what will happen? The motor will rotate, right? So, but you have to be aware about whether the motor can be operated by using a 5 voltage motor or not, right? So if the motor is rated to be operated by 5 voltage, then it will work. If the motor is rated for 9 voltage, what will happen? If the motor is for 9 voltage, what will happen? We have 2 options, right? We can use L298 motor controller to operate this motor either way, right? Another way we can use is we can use a relay to operate this motor if it is 9 voltage, right? This is the thing you have to know, right? So you don't have the components. All the components are worked with 5 voltage. Some components may be 5 voltage or 9 voltage or 12 voltage, right? But I suggest you to don't work on the AC current circuit. Maybe I told you to do not work on 240 voltage home supply AC current, right? So if you obtain the relay and you can work and connect these things as well, right? But I strongly uh, saying it to you that don't work on this 240 voltage AC home current supply, right? So we are going to learn these things, right? So when you study in your future, that means when you grow up and you study in your A levels or maybe in your university period, you can do projects by using this one, but not now, right? After you have learned about the electricity and current, how much is you learn the science, then you can practice, but not now, right? So after you enter the university and learn these things, you can uh, work with these things, right? Right. So here, so we have to remove these wires because these are useless, right? So we have to control this motor, right? So similarly, so let's say as an example, I'm going to explain it in a way, right? It's an example. If it is 5 voltage motor, this motor is rated for 5 voltage, right? So then we have, if we connect this one and this one, what will happen? The motor will be turned on for always. That means the motor will be rotating always, right? So for that, we have to control this one. Maybe we have to obtain a GPIO pin, right, and ground it if it is a 5 voltage, right? So if it is not a 5 voltage one, if it is 5 voltage, this circuit is okay, right? So we give power to this motor, then it will rotate. That means the pump will be activated, then it will work, right? If it is not 5 voltage, if it is a 9 voltage one, because we can only obtain 5 voltage or 3.3 voltage from Raspberry Pi. That is the problem, right? So if it is 9 voltage, we have to use what? An additional component we have to use. Can anyone tell me what is the additional component we have to use? What is the additional component we have to use? The component named as relay, right? Relay. So while you are selecting the relay, you have to be aware about selecting how the relay should be activated, right? So from the Raspberry Pi, it will provide 3 voltage or 5 voltage, right? So we have to select a 5 voltage relay, right? 5 voltage relay and a single channel because we have only one motor to be activated, right? For that, we have to select a single channel relay, right? So this is a 5 voltage single channel relay. I will show you, right? 5 voltage single channel relay module. You have to select this one, right? So in here, it is attached as 12 volt. Maybe it is attached as 12 voltage. Sub relays are attached as 5 voltage. You have to select the 5 voltage one. If you select the 12 voltage relay, then the relay will not be activated because the voltage is not enough to activate the relay, right? So definitely you have to select the 5 voltage relay here, right? So here we have to select a relay. So maybe we can select a relay. Right. So after that, we have to see the wiring diagram, maybe the relays wiring diagram, right? So this one, right? If you see that here we have these diagrams, right? So basically, this is the coil. That means this part and this part, right? So what are the parts? We have to slightly zoom it to see that. So here we have relay 2 terminal, second terminal, first terminal, fifth terminal, sixth terminal, ninth terminal, 10th terminal. That's all, right? So we have to select what is the terminal. Maybe we have to rotate this one. One U1 relay. We have to see the wiring diagram of the relay. Right? So then only we can connect. So here we don't see any wiring diagram. Maybe it's not clear. So basically you can see that this is also a 12 voltage. So let's say, right? Let's say in a way that this is the coil, right? So this is the coil, right? So this left side part is the coil, right? Then we have to obtain Raspberry Pi, right? Raspberry Pi GPIO pin, right? So we have to obtain a GPIO pin and supply it to the coil. So basically we don't see the coil here. You have to see the manufacturer prescription, right? In order to wire these things. So I'm going to wire this one here, right? So you have to obtain a cable and connect it to this one, and then these things should be grounded, right? So that we can activate the coil, right? So if the power is given from this GPIO pin, then the coil will be activated, right? On the other side, right? On the other side, we have to obtain a 9 voltage battery, right? We have to obtain a 9 voltage battery, and then we have to obtain the positive terminal and connect it to the common terminal, right? Common terminal is this one, right? And then we have to obtain this one, this another relays another terminal, and then we have to connect it to the motor, right? On the motor, we have another terminal. That terminal is connected to the battery's ground. That way, the battery's circuit will be fulfilled by this path, right? So the 9 voltage is coming from this one, and here this is a switch. Relay is a switch, right? So this relay will act as a switch. So these are disconnected from here, right? So then it will come from here, and then it will pass through the motor, and then the motor is grounded, right? So if this knob is connected with this one, then the motor will be activated, right? In order to connect this terminal, we have to provide an electrical signal through this coil, right? If we provide electrical signal through this coil, then only the relay will be activated. If the relay is activated, then the motor will be rotating, right? This is how we wire, right? So basically, I think it's better to obtain another relay, 5 voltage relay, maybe this one. So we have, this is also a 12 voltage. Maybe we don't have the relay module here. That is the problem, right? We don't have the. So in this relay, it is very simple to explain. So probably you can obtain this one, right? So in this relay, you can, this is a relay module, right? You can simply connect this one, right? You can obtain a battery and then connect it to a common terminal, and then you can obtain another terminal and connect it to a motor, and then the motor is to be grounded. That is what. This is how we can wire, right? This is how we can wire this relay. And then on this side, right? On this side, we have to power up this module also, right? So then we have to obtain from a Raspberry 5 voltage. We have to give power V in, and we have V in here, V in here, VCC here, and then we have to ground it from Raspberry 5. Then also we have to obtain a GPIO pin, maybe GPIO 6th pin, right? Then we have to obtain the 6th pin and attach it to this one in. Now we have wired up all the components, and then if the soil moisture sensor, right, is activated, then it will, the 5th signal, Raspberry 5's 5th signal will receive that one. We can program by using the Scratch software. If the 5th pin is activated, then it should activate the 6th pin output, right? Then the 6th pin is connected to this one, so then the relay will be activated. If the relay is activated, then the current will be flown through the motor, then the motor will rotate. So simply we can make the circuit achievable, right? So do you have any problems or doubts regarding this one? You can ask me. So what about our next class? We have only, in basic robotics course, we have only 2 classes, right? So 2 classes left. So what will be our next classes? What is your willing? Do you want to learn the programming session or project management session? What about that one? Or maybe some kinds of project, how we can make a project. What do you want to learn? You can unmute and say, or maybe in the group also we can discuss those things, right? So in the next class, we will see those kinds of things, right? Okay.